Hello and welcome to this new DIY Engineers video. In this video, I'll be going over the joystick and how to use it with Arduino. I'll go over the pins, how to connect it to Arduino Uno, programming it in Arduino, and we'll do an example. So stick around and we can see some more. Alright, let's get started. Alright, so this is a joystick. So you can see it consists of two potentiometers, one on one axis and another one on another axis. It also has a push button that you can see here, and when we push it, it engages and you can hear the click. So basically potentiometer in x-axis, the other one, you can easily see it here better, x-axis, and then y-axis, and then you can press it down. So that's pretty much the joystick. Now, what is a potentiometer? Potentiometer is basically an electrical component that is commonly used to measure or control a level of voltage in a circuit. And here we're using it more as a sensor because we can read that output signal and use it to determine how much has been rotated. And in this case, by seeing how much we rotated this potentiometer, we can know the position of the joystick. And since we have two axes, then we can use it to know the total placement of this. Now, how are potentiometers used in the joystick? So, as I said, you have two potentiometers, and simply here we can see, as we rotate this, you can see how this white piece inside is rotating. That means the potentiometer is moving along that axis. And as you move it along that axis, we're going to get a signal that is ranging, in Arduino it will range from 0 all the way to, I think it's 1023. Or 255, one of the two. We'll see it later. And then we'll do the same thing here. So by doing that, you can get the output signal, or basically the position of both X and Y, and it can turn it into the total direction that you're moving the joystick. And the push button will basically, once you push it or not push it, you're gonna get one output signal on this pin right here. Whereas you can see we have also, one second, I went ahead and removed the actual joystick head so you can see it better. But you also have VRX and VRY, which are the outputs for the joystick position, and then we have the 5 volts in the ground to power the joystick, and then, as I said, SW for the joystick push button. And then you can see here, I mean, as I move this, that just moves one, and then this other two rings move it in the other direction. Now let's talk again about the pins. So the first one, that's SW. That's the push button that outputs the push button signal. This is connected, and basically when the button's not pressed, the voltage is equal to the maximum voltage, so 5 volts. And the button, sorry, well, that's when it's not pressed. When it is pressed, you're gonna get 0 volts. Then you can see here, we got VRY. And VRY is the pin connected to the wiper of the potentiometer that measures the position of the joystick along that y-axis. That voltage pin is going to vary and range from 0 volts to 5 volts. And the same for the x-axis, or VRX. We got that one over here, the one in the middle. So what about the other pins, right? I mentioned that you have those two. Those are 5 volts and ground. So now, how do we connect this to our Arduino Uno? So to connect our joystick to our Arduino Uno, we start here at the top with the ground, which will connect the ground, 5 volts to 5 volts in the Arduino. We have here VRX. We'll connect that one to your analog input A0. We got VRY. That'll go to analog input A1. And then we'll have the push button SW here to digital input number 2. Now, for our first Arduino test, go ahead to DIYengineers.com, specifically the link that I included in the description to this video, and then scroll to this section that says first test of joystick with Arduino Uno, and go ahead and copy this code and paste it on your Arduino ID. Now here's the first Arduino code, and you can see we have X pin, which we'll define a variable and set it equal to A2. We'll have A1 for Y pin. We'll have the button pin as 2, that's the digital input 2 that we talked about earlier, and button state as 0. Then over here, we will set the pin mode to input and the serial to begin. We will go ahead and read the X value and Y value as analog read per the analog inputs of X pin and Y pin that we define here. We'll read the button state as the digital read for the button pin, so digital input 2. And then we'll go ahead and use the serial monitor to print the values of X value, Y value, and the button state. Now let's go ahead and upload that Arduino code. Alright, so if I open the serial monitor, this is from me doing nothing. If I push it up, Y is 0, and X is 522. If I push it down, 523, 522, and Y is 1023. Now, 1023, we can see if I go to the right is X equals 1023 and Y equals 510. And if I go to the left, X equals 0 and Y is 490 something, almost 500. And if I do nothing, you can see X is 520 something and Y is 499. Now, you could see that the extremes are 0 and 1023. Now, what is half of 1023? It's roughly 512. So you can see even now that when doing nothing, my output is not necessarily what we would like it to be. Let's check the push button. If I push it down, 0. If I don't push it, it should be 1. But even then, it's kind of like inconsistent and it seems to be jumpy. So over the next few different iterations of the Arduino code, we'll be working on this. Now, before we go ahead and make any changes to any sort of code, we gotta look at what is it that we want. So ideally what we would want is when the joystick sets the center, that X output is 512 and Y output is 512. When we go right, we get 1023 and Y is 512. When we go left, it's 0 and 512, and up is 512 with Y is 0, and down is 512 with Y 1023. And then when we push down, we get 0, untouched for the push button will be 1. That's what we would like to see. Now, if you go back to DIYengineers.com and you keep scrolling down, there's a section called Calibrating a Joystick that will have this updated code. Now, what do we have? Near the beginning, we have this Xmin, Xmid, Xmax, and Ymin, Ymid, Ymax, which basically define the extremes and the midpoint, which we were seeing it as 522 and 499. So we then go ahead and we want to map this, right? This is what we were seeing. This is what we want it to be. So we're going to use the map function and we'll put the X value, which is what we're measuring, and we'll have min and max, and then we'll have what we want it to be for that X min and the midpoint, 0 and 511. And then we'll go to 512 and 1023. This is for X versus the mid that we were seeing as 522. So you have to put here the values that you were seeing for your midpoint. 499, 1022 for my example. So I do that, and then I do the same for Y, where we use the map function, Y value, min mid, min max, 0 and 511 and 512 and 1023, which is what we would like to see. And then after that, we're gonna print it out on the serial monitor. So let's upload that and see what we get. Done. All right. So now you can see it is definitely more steady and in the center versus what we wanted to see. For this one, since we haven't really fixed the push button, I didn't print that. But it's now behaving much better. When I go horizontal to the right, I get a Y that I think is consistent with near the middle. If I go down, straight down, at least X is near the middle. Same thing if I go up, and if I go left, X is 0 and the Y is near the middle value. So this is now calibrated with respect to X and Y axis. Now let's go ahead and work on that push button. So again, go to DIYengineers.com and copy the code for fixing the push button. Now, if you read the description on the website, you will basically see that I used a pull-up resistor that's embedded in our Arduino. Now, a pull-up resistor is a resistor connected between the input pin and the positive power supply voltage, and it serves to ensure that the input pin is a known state when no external signal is present. So this is basically going to make our reading from our push button, much more stable. So here we do it as pin mode to input pull up. That's all we're doing. That's all we're changing. I did make sure to now print the button state. So let's now go ahead and check out the result. So we will upload it. And now we can see that when I push down the button, I get a 0 that is consistent. And when I remove it, it's 1. And we don't see any of that jumpiness that we were seeing before. So now let's go ahead and jump to an example. So now for our example, I went ahead and used a Neolight ring LED, which basically has 16 individual LEDs, as you can see here, throughout the ring. And I'm gonna use it to light up the LED in the direction in which the joystick is pointing. When it's not pointing at anything, it will basically light up all of them at a lower intensity. And when I push the push button, I will change the color. So here we have the circuit for it for this Adafruit Neo Ring LED. I'll put the link in the description. And this is how you wire it. So same thing for the joystick, but the Neolight has 3 pins. One of them will connect to a 3500 ohm resistor that then goes to IO pin number 6. We will put the 5 volt to 5 volt and the ground to ground, common ground with the same as our Arduino. And we'll make sure to put a capacitor as shown between our 5 volts and ground. So now with this, go to DIYengineers.com and copy the code. Now before we can run this example, we need to install the Adafruit NeoPixel library. So go to Sketch, Include Library, Manage Libraries, and that'll open the library manager. We'll have to wait a little bit for it to load. Once it loads, type Neo on the top, Pixel, and you'll find the Adafruit NeoPixel library. This third one over here. All you have to do is click install and let it install. That's it. So now that we have the library installed, let's take a look at the code, which again, you can copy from DIYengineers.com. Just keep scrolling down into the example. And the section will be called Example Joystick with Neo Ring. So first, we make sure to include our library from Adafruit NeoPixel. We'll define the LED pin as number 6. The LED count is 16. And then we'll have Adafruit NeoPixel, pixels, LED count, LED pin, Neo GRB. And then plus the Neo underscore kilohertz 800. This is the same as what we had before, which includes the calibration of our joystick and the middle value without the calibration. We have the button state, we'll have angle, which we'll use for keeping track of the variable for the position of our joystick. We'll have N0, N1, and N2 that are specific variables that we'll be using. And then C, same thing, just for tracking. Here, I entered the 6 colors in GRB, which is green, red, blue, values that I want to display on the Neo ring when I push the push button. So it's going to switch between red to blue, etc. So this is the first value of the first color, second value, third value. So this defines the red, the next one's 00255 that defines the blue, and so on. So if you want different colors, you could change that. You would have to change the 6 since this defines the 6 colors, but you can tweak these numbers as you want for your specific example. So here we have the serial begin, we'll have the pin modes, and we'll do pixel begin. Here's the same, right? We have the X value, Y value of the button. We're doing the mapping for the calibration. And now here we'll calculate the angle as the arctangent, so we'll use the tangent function. And we'll have to make adjustments because before, remember, the center had like 512. And I really want to make it now such that the extreme on the right gives me a positive 512. Center is 0, and on the left is a negative 512. So it is consistent with the typical positioning of a circle with triangles that we use for the arctangent to calculate the angle, because that's what will be needed for the arctangent function to give me the angle relative to the horizontal per normal convention of X and Y axis. So I modify my Y with negative Y mapped plus Y mid, this being the value that we're getting, and then plus Y mid to offset it, and the X map minus X mid, again, for the same conversion. Once I do the arctangent, I multiply times 180 and divide it by pi to get it in degrees, since this is going to give me radians. So then if the angle is less than 0, angle equals angle is plus 360. This is done because otherwise, instead of telling you that it's at position 270 degrees, it just gives you a negative 90. So I'd rather if it gives me positive numbers, so that will be instead of negative 90, it will be negative 90 plus 360, which is 270. Again, this is for keeping track of the push button. So as I push the button, it's going to go from 0 to 1 to 2 to 3 to 4 to 5. And if it's 5, it just goes back to 0. And that way I can use that to use our matrix that we showed before to tell the Arduino which LED color to light up. So then here, if the absolute value of the positioning of the restated X and Y after the disadjustments is greater than 50, which means you're at least moving it out enough of the center, it will go ahead and depending on the angle, right, that we're showing, I went ahead and divided by 225 so that we have 16 sections or regions. It will go ahead and know which LEDs to light. And so I will be lighting up the main one based on the angle that it was detected. That'll be N, right? So we're rounding. That's why we divided by 255 minus 1. 0 because 0 is the primary one. The LEDs go from 0 to 15, not 1 to 16. And then I use this to tell it which LED is before and after. So if it's 15, that's the last one. The prior one will be 14, but the next one will be 0, which is the first one. If it's 0, we know that the one after that is 1, the one before that was 15. Otherwise, it's just n minus 1 and n plus 1 to define what will be at right before and after those. After that, I simply go ahead and clear all pixels and set the pixel colors to light up. So we're going to light them up as C1, C2, C3 per C, where C was the count that we got before for the color. So that's defining which color. And then here, for the pixels that are before and after the primary one that defines the position, I multiply times 5 divided by 255 to make it light up at a lower color intensity. Else, this is basically saying if we're outside, meaning we're not outside this range, meaning the joystick is near the center, just go ahead and light them all up with low intensity. After we do that if statement, we're going to show, meaning show whatever, either this or this, and light them up. And then I was also printing the values of X, Y, button state, and the angle in case you wanted to troubleshoot and see. So now let's go ahead and check out this example. So here we have it. We have our joystick. We have our 16 ring LED. We have the resistance and capacitor that we showed in the circuit. And they're all connected here to our Arduino. And I'm going to connect it here to 5 volts. So there it is. You can see there. Let me turn off the light. So we have a low light when the joystick doesn't do anything or when it's at center. And then as soon as we move to a specific location, so here I'm moving right, it points right. If I go left, it points left, down, up, and then I can do a circle, one direction and another. If I tap it, change colors, tap it again. One more time. Now we're back to red and blue. Red. as the example. This concludes this video. If you liked it, please give it a thumbs up and subscribe. See you in the next one. Bye.